All right, so we're going to do questions 9, 13, 14, and 18. So starting with question 9, it says, play the lottery. Some people play state-run lotteries by always playing the same favorite lucky number. Assuming the lottery is truly random, is this strategy better, worse, or the same as choosing different numbers for each play? Explain. So this is a lottery type question. You may or may not have played the lottery. Ethan, can we chat for a minute about the lottery? Or I said minute, I mean like 3 seconds.
Okay.
So you understand the lottery is just random numbers every week, right?
Yeah.
So is there a difference from playing the same set of numbers, right, every week, or changing it every week, or doing random every week, or whatever? Is one better or worse than the other, or are they the same thing?
Should be the same thing, shouldn't it? Since it's all at random.
Should be, right? It should be the same thing. It's kind of like flipping a coin, right? It doesn't matter what I just did when I flipped the coin. Every time I flip that coin, it should be random, right? Now, if I did it over like 100 times, it should be 50-50. But just because I rolled head, or just because I flipped a coin and it was heads right now, it doesn't mean the next time I flip a coin, it's going to be tails to balance out. Like, random probabilities don't work that way. Every time you do something, it's random each time you do it, so it's just random. So it doesn't matter which one you pick, it's going to be random every single time. So whether you pick the same number or numbers every week for the lottery, or if you pick random every week, the strategy, it's the same. If it's truly random, okay, it should be the same. Now, I have read stories where people have actually looked at stats on lotteries, and they go back like years and years and years of data, and they'll find numbers that occur more often than other numbers to the lottery, and they've actually played those numbers, and people have found success. They then like get in trouble and are not allowed to play the lottery anymore after they've won like a couple $100,000 or a couple $1 million. It's pretty funny when you read these stories. But sometimes some numbers actually come up a little more often, and they say, oh, it's not truly random because they're using maybe the same program, and that program has some faults in it or something. So yeah, technically speaking, you should have the same chance playing a lottery if it's random, right? If you choose random numbers or the same numbers. If it's truly random, then it doesn't matter if you have the same numbers, 1, 2, 3, 4, 5, or they're random. It doesn't matter. It should be the same probability. Cool. Thank you, Ethan. You answered exactly how I wanted you to answer. I appreciate it, sir. Okay, question 13. A statistics student properly simulated the length of checkout lines in a grocery store and then reported the average length of the line will be 3.2 people. What's wrong with this conclusion? Russia, are you there? Can you talk to me for a moment, kiddo? Miss Russia.
Hi.
So, how's it going? So, you just did a simulation and you found that the average line at a grocery store is 3.2 people, okay? Is that a good conclusion, or should you change that a little bit? Or I'm sorry, this right here is a bad conclusion. 3.2 is a bad number for this kind of problem. Why is saying the average length of the line is 3.2 people, why is that bad? Well, there's a few things, okay? And thing number one, now I know we kind of just rushed through this. You probably haven't read this chapter yet, okay? You guys, I recommend reading this stuff. You guys have time, please. But there's two things here. Number one, this says the average length of the line will be 3.2 people. So you see how they said will be, okay? It's being very exact. And hopefully you've learned so far with stats is we like to kind of keep things kind of like fuzzy, kind of vague, kind of like soft, okay? And not like this perfect, like it has to be this. So
right.
It should have been better. So there's two things better, or two ways to make this better. Way number one should have been the average length of the line in our simulation was 3.2 people. Or maybe you might make like a pretty that the fact that they said will be 3.2 people, like they're making like this absolute prediction, and that's kind of like bad. You want to kind of be a little more fuzzy with it. You kind of want to say, according to my simulations I did, I would make a prediction that it's about 3.2 people, but you shouldn't say it will be this. It's kind of too like it's making too specific of a conclusion. Okay, like you can't always make a conclusion like that. But thing two, Russia, is when it says something like 3.2 people, there's kind of a time and a place to say that. But for right now, they kind of want you to round a little bit. So would you select 3 people or 4 people? Would you round up or round down?
Round up.
So for problems like this, I would say either one is right, okay, as long as it makes sense to you, okay? I mean, generally speaking, you want to kind of round like to the nearest number, like round down or round up. But sometimes in some cases, depending on the problem, since you can't have 3.2 people, you might want to say the average length of a line is going to be either 3 or 4 people. Maybe something like that might be a better answer. You know what I mean?
Yes.
So I think you're right to say that rounding up would not be bad. Okay. And if you say 3 people, you might be too small. If you say 4 people, it might be too big. So if you just say the average length of the line, according to our simulation, was about 3 or 4 people. Like you would expect to go to the store and there would be lines of about 3 people in each line. You know what I mean?
Yeah.
Okay. So that's pretty much all. So make sure when you guys are answering your questions, if you have a conclusion to write, that you're mindful about a few things. About you can't have 0.2 of a person. So maybe you might want to round it down or round it up, or talk about the 2 numbers around it, 3 and 4. Use both numbers. Or maybe like the average length of the line was a little more than 3 people, something like that. Maybe. Okay. You don't want to be exact with your stuff. Cool. All right, number 14, another wrong conclusion. After simulating the spread of a disease, a researcher wrote 24% of the people contracted the disease. What should the correct conclusion be? Miss Medina. Eliana. Miss Medina, are you there? You can't hear me or something's going on. That's fine. How about Mr. Lopez? Dominic Lopez. OMG. Aaron, what's happening, Aaron? Can you hear me, Aaron? Mr. Scheffler.
Yes, I can hear you.
What's up, man?
Nothing. How about you?
Doing all right. Just teaching a class, right?
Yeah.
So if a researcher simulated the spread of a disease and they said 24% of the people contracted the disease, why is it incorrect and how could that be better? And think about what I was saying with number 13. You want to be a little fuzzier, right? You don't want to be so exact with your stuff. What's wrong with 14?
It doesn't seem like it's like enough information.
Well,
that makes sense.
I think we have enough information. I think the issue is there was a simulation that was done, and then the researcher was saying 24% of the people contracted the disease, right?
Yeah.
So do you play football or follow football?
Yeah, I follow football.
All right. Do you ever watch Super Bowl? Like every year I usually watch Super Bowl, regardless of my team. I like the Steelers, but they're not always in the Super Bowl. Like they only go in the Super Bowl like once every 10, 15, 20 years. You know what I mean? But I still watch every year. And usually before the game, if you know anything about John Madden football, right? The old Madden football games that still come out every year. I've been playing since Sega Genesis back in like 1994 or something like that. 93, 94 when the first game came out. Didn't even have all teams at the time. It was kind of funny. But usually every year before the Super Bowl, they'll say, hey, Madden football, because I think they're probably sponsoring the Super Bowl, or they probably have like some money or advertising, but they'll say, hey, we had 2 computer teams play. We had, let's say it's the Steelers versus the Packers, and we had the Steelers and Packers play Madden football, computer versus computer, and in that simulation, the Packers won 21-14. So is that going to be the answer? Like, is that the actual like answer to the Super Bowl?
No,
No.
because it's not the actual Super Bowl.
Right. It was a
Oh, I get what
simulation.
you're saying.
What's that?
I get what you're saying because it's a simulation, so it's not like accurate.
Right. So maybe what can be better way to say this was maybe according to our simulation, we would expect about 24% of the people to contract this disease. Does that kind of make sense?
Yeah.
It's kind of like here's an answer. Like, yes, we got an answer, but this is where I'll be 100% honest with you guys. Okay, with everyone here, I swear. Stats is one of my least favorite maths. Okay, why? Because it's so fuzzy. And it's one of those things where as a math person, I naturally want to go to one answer and I want to say the answer is 24%, put a circle around it and move on. That's just what I was used to as a kid, right? And I got to like high school, got to calculus, and I still had answers that were like x equals 5, or the area of this thing is like 24 square feet. Like, you have answers, right? But with stats, it's more critical thinking. Stats is this higher level stuff, and stats really is only like 150 years old max. Like there's some old concepts for stats, but most things we do are like actually fairly new, according to like education and like and math, right? They're fairly new concepts. And a lot of this stuff is like, you run a simulation, you get an answer, you're making a prediction, but you have to kind of keep your predictions in check. You have to kind of like say, according to the simulation, we would expect about 24% of the people to get the disease. Why? Because it might be higher, it might be lower, but according to our simulations, we think it would be like this. It's kind of like, according to, let's say I flip a coin 5 times and I get heads 3 times and tails 2 times. And I say, hey, according to my simulations, when you flip a coin, you get heads 60% of the time. You might flip a coin and you might get tails 80% of the time. You know what I mean? Like, everyone's going to be a little bit different. So you have to be careful with your answers. And so just be mindful that you don't do these exact answers of like, oh yeah, this is going to be the perfect thing. It's probably kind of like you probably heard with the coronavirus the last almost year now at this point. You keep hearing different numbers, different information. Oh, it's 1%. Oh, it's 3%. Oh, it's this thing. Oh, it's that thing. Oh, this number, that number. It's not that people are wrong. It's just how they're phrasing it and how people are interpreting it are kind of getting things mixed up, okay? It's this whole idea that, you can have percentages, you can have simulations, but in the real world, things change a little bit. There's not always a simple, like, yes, no, like, flow chart of like easy way to like tell what's going to be the answer, okay? There's going to be some weird stuff. There's going to be some changes. There's going to be some little slight things that aren't accounted for. They're going to make your numbers go up or go down, okay? So just be very, very, very careful, you guys, when you guys write your answers out, that you don't just say, bam, okay? You have to put in context that you just are doing, or someone else had done, a simulation, and you're just saying, hey, I'm making this prediction of about this amount, okay? You got to leave it open to be a little fuzzy and kind of like, sometimes you'll have an exact answer, but in this chapter, in this unit, the things that we do, we're just making predictions, and we're just kind of like, well, according to my simulation, this is what I would expect. Now, when I get my actual answer and it's different by a little bit, I just made a prediction, and I was close. Like, maybe you're exact, but usually being exact is like not what you're aiming for. You're just trying to get close. All right, thanks, Aaron. Appreciate it. Okay, so what we haven't done yet is that we haven't done any skills yet. We actually haven't done anything for this chapter yet. And that's kind of what we're going to get to right now. So this is for the recording. You guys, this is going to be some fun stuff here. So we are going to take a look at question number 17 and 18. So 17 says, in the chapter's example, which is earlier in the chapter, if you guys read through the book, 20% of the cereal boxes contain a picture of LeBron James. So think about like a Wheaties box, right? And you open the box, and inside's like a random, there's say 3 different celebrity athletes, right? Like LeBron James, Danica Patrick, and Serena Williams. Which you guys like, who the heck's Danica Patrick? I know she already retired. She's a race car driver. But there's like, it's not an equal spread of these athletes' pictures in these cereal boxes. It says 20% have LeBron James pictures in there. Okay, 30% are Danica Patrick, and 50% is Serena Williams. It doesn't say 50%, but 20%, 30%, that means 50% would be Serena Williams. And it says, suppose you buy 5 boxes of cereal, estimate the probability that you end up with a complete set of the pictures. Your simulation should have at least 20 runs. Now, for the sake of time, we're not going to do all 20, but I'll show you guys one way of how to set this up, okay? So let's look at some of the information that we were given. Okay, so I'm going to go ahead and do chapter 10, practice. And it said something about 20% for LeBron. Oops. %30 for Danica Patrick and 50% for Serena Williams. I don't want to mess her name up. All right, so I'm going to go ahead and say L for LeBron, D for Danica, and S for Serena Williams. Okay, and here's how we run a simulation. We're going to be using a random number table. You can use your book, once again, the appendix, page 123, or that link that I provided from the random number table from your website. Okay, you can even type in random number table online, and you should get a lot of options for random number tables. Okay, now as you see, there's a ton of numbers to look at. You just got to pick some to look at, and I'll show you one way to do it. Okay, so I'm going to start from this top left box from table 1. Okay, I'm going to just go ahead. It says you're going to open up 5 boxes. Those 5 numbers are going to represent the 5 boxes I open. So what I have to do is assign those numbers to the box I'm going to assign, yeah, these celebrity athletes to the numbers from the table. Okay, so if LeBron James is 20% of the numbers, let's consider the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, I've got 10 numbers there, right? If you count that up, 1 through 9 is 9, plus the 0 creates that 10th number, right? So there's 10 numbers there. 20% of those numbers are going to be LeBron James. So 20%, and I'm letting you know now for this chapter, for this whole unit, I'm going to try to keep it easy with just 10%, 20%, 30%, 50%. You can go in more detail, and I can show you guys that if you guys want. I can tutoring or whatever. I can show you I can be more exact and more specific with stuff. But for right now, I'm just going to take 20% of these numbers. 20% of 10 numbers is 2 numbers. So for LeBron, I'm going to do numbers 0 and 1. Whoops, good job. I'm going to say LeBron James is going to be 0 or 1. So a 0 or 1 would be LeBron James on that number table. Danica Patrick, I'm going to do 2, 3, and 4. So Danica, Danica, Danica. And then for Serena Williams, okay, she's going to be 5, 6, 7, 8, 9. Okay, 5, 6, 7, 8, 9. That's 5 numbers, which is half of all 10, which is 50%, right? So she's going to be 5 through 9. Okay, so Serena, 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 and Serena. So hopefully you guys kind of saw how I set that up. Once again, since there's 10 numbers, one number represents 10%. So if 20% is LeBron James, 2 numbers would be right that 20%. 3 numbers would be the 30%. 5 numbers would be 50%. If you don't have pretty numbers like that, there's other ways you can do this. There's like a lot of different ways you can do this. I'm just showing you guys one way, but there are more advanced ways to do that, and I don't want to get there just yet. But if you have questions, I will try to answer those during tutoring and stuff. So what we're going to do is, and for the sake of being online, if we were in class, I would just give you guys a printout and you could write on the printout. Okay, so for now, we're just going to copy these numbers down. I'm going to go ahead and do it said. You see how it says your simulation should have 20 runs. They mean 20 trials. Okay, that's what it means by a run. Okay, so I'm going to go ahead. I'm going to do 5 trials. I'm going to do. These are going to be my trials. Here's trial number 1. Trial number 1, I'm going to write those 5 numbers. 1, 1, 1, 1, 1, 6, 4. Okay? So my first trial, this is me opening up 5 boxes of cereal looking for pictures of LeBron James, Danica Patrick, and Serena Williams. Okay? And they want to know, going back to the question itself, they want to know probability about a complete set of pictures. So a complete set of pictures would be getting all 3. Let's see. LeBron, 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 and then Serena and Danica. So did I get all 3? Yep, I sure did. That was a successful box of 5 boxes of cereal. Let's try another trial. Okay. So I'm going to go ahead. I'm going to try these 5 numbers now. 3, 6, 3, 1, 8. So 3, 6, 3, 1, 8. 3 is Danica Patrick. 6 is Serena Williams. 3 is Danica Patrick. 1 is LeBron. And 8 is Serena. So did I get all 3? I did. Okay, I'm going to do that 3 more times. Now the book, remember I said do 20 runs. So I could do this 18 more times, but for the sake of time, I'm just going to do 5 more times, okay? Or 3 more times. I'm going to do trial 3, trial 4, and trial 5, okay? So I'm going to say 75061. I'm going to do 37674. And then I'm going to do this one over here as well. 26320. 26320. All right. So let's see. Whoops. So here's one strategy I've seen students do that they seem to like, and I've kind of picked it up, is you see I have 0 and 1 is LeBron. I'm going to go ahead and do LeBron, LeBron, LeBron. And then 2, 3, 4 is Danica Patrick. D, 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 D. And then 5 through 9 is going to be Serena, Serena, Serena. So there's one way to simulate it also, okay, is to kind of just skip around and do the ones that are kind of easy, just kind of do small chunks at a time. So for trial 1, once again, I open up 5 boxes of cereal. LeBron, 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 Serena, Danica, Danica, Serena, Danica, LeBron, Serena. These trials 3, 4, though, if you notice, I didn't get all 3 pictures of the athletes, okay? But my 5th trial, I got it again, okay? And I could do this 20 times, right? I could do this 20 times because that's what it told me to do. Now, the more trials you do, the more simulations you do of this, the better your answer is going to be. The more close to, the better prediction you're going to have, okay? Just like flipping a coin only a couple times, you might not get a good picture, but if you flip a coin like 100 times or 1,000 times or 1 billion times, it should line up to that 50-50, right? With flipping a coin, it should, okay, over a big sample size. So the same kind of thing happens with these simulations. If you do a small sample, you're going to probably have some more error to it, more room for error. So let's not forget about probability. Okay, probability. Whoops. I do not want to make the assumption that you guys are all awesome with probability. So I want to remind you that probability is the ratio of favorable outcomes divided by total outcomes. Okay, it's kind of like a big thing here you got to remember. Okay, probability is the ones we wanted divided by the total amount that we did. So out of these 5 trials, okay, out of the 5 trials, we had 3 successes. So 3 out of 5 or 0.6. Okay, so you would say something along the lines of estimate the probability that you end up with a complete set of the pictures. So you could say something along the lines of something along those lines. Probability of getting all 3 pictures is 0.6. Okay, it's just one way to say it. But now, if I did different numbers, let's say on this one, if I did like this table over, let's say these numbers here, I'll probably get I might get a different answer. It might be the same, but I might get a different answer. Let's say I pick these. Let's say I pick this one, and this one. Like say these 5 here going down, I might get a different answer. Okay, and this is where it gets kind of fuzzy. However, if you did 20 of these trials or like 100 of these trials, then I think it wouldn't really matter at that point. At some point, all the answers should kind of get to around the same probability. Okay, and that's kind of where the next kind of stuff is going to go to. But for right now, we're just running simulations. All right. So here's one way to do the simulation, or is to do these trials. Okay. Any questions so far before we move on to the next section, or the next kind of question, which is using these tables in a little bit different way?
How did you use the tables?
How did I use the tables? So they wanted me to do a simulation. Okay. So what they mean by simulation is to practice opening up boxes of cereals. You understand cereal. The kids' cereal usually has like toys and stuff in it, right? Like, well, they don't have it much anymore. But when I was a kid, it was always like, dude, well, I'm going to buy Cookie Crisp because it's got an action figure in it. And the Fruit Loops has like stickers in it. You're like, I want the action figure. I don't want stickers, you know? So like each one of those numbers. So what I did was I copied down 11164 and then 36318. Like see these numbers over here. I just copied those numbers down because they're all just random numbers. Okay, I could have chosen any sets of numbers. I just chose the top ones and I went left to right. You know, I went to all the way to this one here. Okay.
So it doesn't matter which ones you choose?
No, it does not matter at all. Okay, and in fact, this is where this gets a little weird and crazy, because if I let you guys pick your own random numbers like this, like your own table, you're gonna probably have slightly different numbers. So usually what you'll see on a quiz or a test is I will give everyone the same like numbers to use. So you see how this one's got like these questions here, like these random numbers across here?
Yes.
These are legit just random numbers that they give you to use. Okay, so the way this simulation was set up was each number represents opening up a cereal box. So this has 5 numbers, so it was 5 cereal boxes. But what I did was I attached each number to one of these celebrity athletes, okay? And since it said 20% was LeBron James, I picked 2 out of the 10 numbers. It said 30% was this lady, Danica Patrick, who was a famous race car driver. Okay, she did 30% of the, she was in 30% of the boxes, like her picture was in 30% of the boxes. So 30% of 10 is just 3 numbers. And so if I opened up a 0 or a 1, right, if I had a 0 or a 1, that meant that box contained a picture of LeBron James. If it had a 2, 3, or 4, that means that box was Danica Patrick. And that left us 5, 6, 7, 8, 9, which is 5 numbers. Those 5 numbers are Serena Williams, which is 50% of the boxes. So according to my little, this is kind of like a key or a legend. You guys know when you see like a map and it's like, oh, if it's red, it represents this. If it's blue, it represents like water. If it's like green, it represents like trees, like on a map. This is basically what you're saying is numbers 0 and 1 are LeBron James. 2, 3, and 4 are Danica Patrick. And numbers 5 through 9 are Serena Williams. I chose those numbers, you know, like I could have picked LeBron James 1 and 2 or any other numbers. I always start with 0. That always seems to be easier in my head. Okay, is to pick like 0 and 1 if it's like, you know, percent. I usually like to start with 0. So I chose 2 numbers to represent LeBron James. I just picked 0 and 1. You could pick 1 and 2. You can pick 8 and 9. You can pick 9 and 0. You can pick whatever 2 numbers to represent LeBron James. And if we do enough trials, it shouldn't matter. Everyone should get similar results if you do enough trials. Okay, so don't freak out about using the right numbers or the wrong numbers. I just picked 2 numbers because it was 20%, and 2 numbers are 20% of the 10 numbers here. So 20%, 30%, 50%. Right? If you think about it. There's 2 numbers, 3 numbers. Like this is my 20%, this is my 30%, and this is my 50%. So you would expect, okay, you guys should also expect for the quizzes and tests and stuff like that for this class is we're going to just use nice, pretty 10%, 20%, 30%, like those nice, good 10% numbers. Okay. If it gets more specific, like 21 or 22%, I can show you guys what that looks like then. But for now, I'm just going to keep it nice and easy. Okay. So one number is going to represent, each number represents opening a box. So like there's 5 numbers, that's 5 boxes of cereal. 5 numbers, 5 boxes of cereal. 5 numbers, 5 boxes of cereal. Okay, so on and so forth. So this last one, for example, 26320. That's 5 boxes of cereal. The first one was represented by 2, which was Danica Patrick. Then the next box I opened up was Serena Williams. The next box I opened up had a picture of Danica Patrick, and then the last one was a 0, and 0 was LeBron James. Okay, so here's one way how to do a simulation is to say, you know what, I'm going to go to the store, I'm going to buy 5 boxes of cereal. That sounds kind of expensive. And so instead, I'm just going to do a trial. I'm just going to see, you know, if I buy 5 boxes of cereal, what's probability that I get all 3 pictures? Okay. Obviously, if you buy more boxes, you're probably, you know, almost guaranteed to get all 3 pictures. Okay. But you don't have all the money in the world to be buying, you know, 100 boxes of cereal. So instead, we're going to simulate it and then try to find like a good probability for it. All right. So that's just one way to do these simulations, guys, is to say, well, probability is 0.6. Okay. Then there is another way to do these, to use these number tables. I'm going to show you a different way to do it. Okay. A different kind of problem. So question 18 says, suppose you really want the LeBron James picture. Let's say you don't care about collecting all of them. You just want the LeBron James picture. Okay. How many boxes of cereal do you need to buy to be pretty sure of getting at least one? Your simulation should do at least 10 trials. So they want you to do 10 trials. Once again, we're just going to do 5. Okay, so this is question 17. We're going to do question 18. We're going to do the same exact numbers here because these numbers aren't going to change. So we're going to use the 0, 1 for LeBron, 2, 3, 4 for Danica Patrick, 5 through 9 for Serena Williams. So once again, here's my trials. Let's say trial number 1. Now for trial number 1, I'm going to go ahead and skip down to, I don't know, this page right here. And I'm going to do these numbers here. Okay. But this time, I'm not buying 5 boxes of cereal. I'm only buying enough it takes to get a LeBron James picture. So what I mean by that is if LeBron James is represented by 0 or 1, I'm going to open boxes of cereal using a simulation until, so I'm going to stop once I get a 0 or a 1. So trial 1, the first box I open Is that a 0 or a 1? Nope. 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 Yes. Okay. So it wasn't until I got my 5th box of cereal that I got a LeBron James. So I'm going to go ahead and say it took me 5 boxes in the first trial to find a LeBron James. The second trial. So once again, I started here and I worked left to right. One strategy. Okay. I'm going to do it again. I'm going to say 3, 7, 2, 8, 4. Okay. None of these have LeBron James. So I'm going to go to the next number. I'm going to go over here and say 0. Oh, there's my 0. So there's my LeBron. This time it took 6 boxes. Okay, let's go to the next. So now I'm going to try it again. Trial number 3. Okay, the first 5 boxes. Holy guacamole cheese cow. Okay, none of those have LeBron James in it. So I'm going to do it again. I'm going to go to the next one. Holy cow. Whoops. None of those. None of those. I'm going to go ahead and I'm going to just do like this. I'm going to do like that. And then it's not until I get to this last set. This was 5, 10, 15, 20. It wasn't until I got to the 25th box of cereal. Holy cow. You guys ever buy like cards, like Pokemon cards or something like that? And you're like, yo, I just want to get a Pikachu. And you got to open up like 25 packs of cards to get that Pikachu card or something like that. Like sometimes it takes a long time in your simulation to figure out how long it takes to get one of these things. Now remember, this could have been 1. It could have been 2. It could have been 5. It could have been 6. In this case, it was 25. So I'm going to keep with my system. I'm going to keep on going. I'm going to do this 2 more times. So this was trial 1, trial 2, trial 3. Here's trial 4. And it says 5 and then 1. Whoop, there's my LeBron James. This time it only took 2 boxes. Okay. So this trial 3 seemed kind of like a weird fluke, right? But sometimes in the random world, that kind of stuff happens. Sometimes you can flip a coin 20 times and get tails over and over and over and over and over again. But eventually it's going to kind of equal out over a big, over a big sample size. Okay, if you do a bunch of trials, it should all kind of tend to one sort of number. You'll see patterns in it. So here's my last trial. Now I'm gonna this set here to do at least 10. I'm only going to do 5. And what I get is 9, and then I'm going to stop at 0. So once again, with trial 5, it was 2 boxes. All right. So the question says, for question 18, how many boxes of cereal do you need to buy to be pretty sure of getting at least 1? Here's where you have to do the average. Okay, and this is where when it asks for a prediction like this, they want you to do the average. So I'm going to go ahead and I'm going to calculate the mean amount of boxes. The mean amount of boxes. So I'm going to add up 5 plus 6 plus 25 plus 2 plus 2. Now, if we were, actually doing this, we might actually cut up the 25 because it seems to be a pretty bad outlier. But you know what? For now, we're just going to keep it in there. So what happens when I have 5 plus 6 plus 25 plus 2 plus 2? Okay, let's clear this. And let's say 5 plus 6 plus 25 plus 2 plus 2. It equals 40. 40 divided by 5 equals 8. Okay. Here's where I'm thinking this seems kind of whack, right? 8 seems way too big. Because look at this, 5, 6, 2, and 2. If you bought 8 boxes of cereal, you might find yourself with 1 or 2 or 3 LeBron James pictures. But you know what? For this problem, we're going to leave it. Okay, we're going to keep it like that. With my last class, we did this. Okay, and we got 4.8 with those numbers. Okay, so you should expect it somewhere in the middle there, but that's okay. That's all right. Okay, these numbers were kind of whack, and that's okay. That's what we get when we get with random, right? Random's not always pretty. So if they wanted you to answer this with a conclusion, we could say something like this. You say you should buy. Now this one didn't need a round, which is kind of weird because usually you got a round, but perfect 8's perfect. I'm not going to complain. You should buy 8 boxes of cereal. To expect a LeBron James picture. Or, I mean, I probably could have said to be pretty sure that you get it, okay? But once again, if you buy if you buy 8 boxes, you know, according to our numbers, okay, 4 out of the 5 times you would have gotten LeBron James. Okay, my last class, like I said, they had 4.8. So 4.8, I rounded up to 5 because you can't buy 4.8 boxes of cereal. So if you bought 5 boxes of cereal, you would get it 3 out of 4 times. If you bought 8 boxes of cereal, you get it 4 out of 5 times. So one more time, when you see a question like this, which was asking us, how many boxes of cereal do you need to buy to be pretty sure of getting at least one? What they want you to do in a question is similar to this. Is just find the average. Okay, find the average, and usually you round up, usually, depending on the problem. Okay, you should buy 8 boxes of cereal to expect a LeBron James picture. Okay, that would be kind of the answer for this one. Once again, am I saying that you're going to get a LeBron James picture? No. I'm saying that according to our simulations, after 5 trials, we found that 8 boxes was the average amount of boxes to get a LeBron James picture, okay? If you know anything about this kind of stuff, right, we talked about it a little bit, okay, is the more trials you do, the better your answer is going to be, because these little weird outliers like 25 or like maybe like I think you saw my last class, they had 1 box once, okay, because the first number was the number we were looking for. Sometimes you have these outliers, okay, but the more you do this stuff, the more trials you do, the more likely it's going to go towards a certain perfect number. Kind of like heads and tails is going to go towards 50-50 over a large trial. Okay, so any questions right now on different ways to do these trials? Okay, this one we did 5 boxes because it said you're opening up 5 boxes and you're looking to complete all 3 cards, right? This one, it said open the boxes of cereal until a certain condition is met, and that condition was, you know, getting a 0 or a 1. Why 0 or 1? Because 0 or 1 represented LeBron James. All right, LeBron. Questions, comments, concerns? I'm going to go ahead and stop the recording. Okay, let's click and click.